First of all, I welcome Dr. Ashalatha Madam for accepting our invitation for presenting a lecture on interpretation and summary of results. Thank you, Madam. And Dr. Ashalatha Madam have started her professional career as assistant professor of agriculture statistics at UAS Dharwad.
Gopal sir, you need not introduce. I think they all know that day sir has introduced. We shall directly start the topic. I don't think there is.
But the main thing is that
the participants have changed.
Participants are same, but we wish to introduce the main things that are.
That's okay. That is okay. We will start. Okay.
Okay.
I think that should be fine.
Okay, madam. As you feel.
Okay. Okay.
Thank you.
Is it audible? Is it clear? Is it visible also?
Yes, madam. It is clear.
A very good evening to all of you, and I thank the organizers for giving me the second opportunity of presenting. That's very important topic, that is interpreting the results, because most of us get the things done through computers, but we do not know how to interpret the results. So with that intention, I would like to directly start the topic. Interpretation of results or summary of findings. You all know that the data should follow normal distribution whenever we take a sample. So if suppose you know the mean and standard deviation of any particular population, the one thing we can talk about the distribution. Mean plus or minus 1 sigma, it covers 68.27% of the total population. Suppose the average marks scored by a person is 70 with a standard deviation of 5. Then we can say that 68.27% of the students have got marks between 70 minus 5 and 70 plus 5. That is 65 to 75. Suppose there are 100 students in a class, then almost 68 students might have got marks between 65 to 75. This is what it means. And mean plus or minus 2 sigma covers 95.44% of the population. That means to say that 70 minus 2 sigma, that is 2 into 5, so 60, 70 plus 2 sigma, 80, 60 to 70. It covers 95.45%. Or in other words, suppose there are 100 students, 95 students might have got marks between 60 to 80. Then mean plus or minus 3 sigma covers 99.73, means almost all might have got marks between 55 to 75. This is what it means. So if at all you draw the sample, we always assume that draw the sample from the normal population. By knowing mean and standard deviation itself, you can talk about the population. That is a very good parameter which is used. That's the reason in normal distribution, we say that mean and standard deviation are the parameters. It can talk about the whole distribution as such. For the simple things, because you have a variety of discipline under your traditional university. So you can just think of this and always draw the sample from the normal population, so that you can talk about this without any much advanced statistical tools. And actually, Gopalji had asked me to touch few things about hypothesis testing, because I'll be talking about how to interpret the result. You should know why we are going for interpreting the results. We in statistics, we have a hypothesis. There is some disturbance. I request all others to mute, please. Actually, whenever we visit some places, for example, let's say the Taj Mahal or something, we bring a small Taj Mahal as a token of our love to our loved ones, maybe our kids or our friends or things like that. By looking into this small Taj Mahal, we feel that, oh, the big Taj Mahal would be like this. The same thing, we are going to estimate the population parameter. All of you will be conducting a research by drawing a small sample, or in a small scale, you will be conducting a research. For example, by taking a sample of 20 COVID patients, we can say that this is a general traits of the patients who are suffering from COVID. You can generalize that based on this 20 patients. So, this 20 are our sample, whereas we are going to generalize about the entire India or entire your UP. That means the population what we are talking about. How do we do it? And one more thing I would like to say. See, none of us have seen Lord Ganapati, but all of us believe that Lord Ganapati has shrunk and he has big tummy. That is our assumption, because we have had that experience from our ancestors, from our the previous generations, which is unknown to us. Real Ganpati we have not seen, but a statue without a trunk, without a tummy, we will not believe that he is a Lord Ganpati. Similarly, here, when we draw a sample, we are going to talk about the parameter without knowing what it is. So we are going to test this through the hypothesis. That is what I'm just touching for 5 or 10 minutes. See, this is a sample. You can just see here. Sample is a small portion of the representative portion of the population. So when we draw the sample, through the sample, we are going to generalize about the population. To generalize about the population, we are drawing a sample and conducting the research. That is the main thing all of us need to keep it in mind. And any characteristic function of the population is known as parameter, and the sample characteristic function, we call it as statistic, not statistics, statistic. So sample mean, through sample mean, suppose there are I would like to know the average height of the Indian population. What I do is I take a representative sample from each country, each state, or from some parts, and taking the average of those 100, I can say that this is a general height of the Indian population. That is what I mean by statistic to parameter. We are going to infer from statistic to parameter. So hypothesis allows us to determine whether enough statistical evidence exists to conclude that a belief about a parameter is supported by the data. See, assumption is nothing but our belief. We just casually, daily we assume. Usually the teachers, they feel that today should be a holiday, or today student should not be there. Today I should have less work, and things like that. So determine whether a certain assumption or hypothesis about a parameter can be justified by statistical evidence, that we call it as a statistical hypothesis. Otherwise, it is just hypothesis, assumption. Whatever we do in our daily life, that is assumption. To make valid decision about the population parameter based on the analysis of the sample. Now I'm straight away going to the hypothesis. That is a statement that something is true. See, today Gopalji would have thought there will be some 20 participants or 30 participants. That is his assumption. It may be true, it may not be true. And statistical hypothesis is always inclusive of some parameters. It could be population mean, it could be population variance, and things like that. There are two statistical hypotheses. One is null hypothesis, another one is alternative hypothesis. Null hypothesis is a hypothesis which needs to be tested. No difference. It is a hypothesis of no difference. When I talk about the height of the people of Karnataka, and I'm comparing the people of UP, then my assumptions say that the height of the UP people is on par with height of the Karnataka people. That is null hypothesis. There is no difference. Mu1 is equal to mu2. Mu1 stands for UP and mu2 stands for Karnataka. Then the alternative hypothesis, alternative to the null hypothesis or opposite of null hypothesis. It is actually no difference. I told you already. Now, one more thing you need to understand, theta is equal to theta 2, we say theta 0, whatever it is, could be mu1 is equal to mu2, or theta is equal to theta 2, theta 0. Now, one is parameter, another one is an estimator of that. So it could be like 2 tail or 1 tail. If the alternatives are 2 ways, when I say null hypothesis, theta is equal to theta naught, the alternative will be theta is not equal to theta naught. It means to say that either it is less or higher. Then it is two-tailed. It could be, if I say theta is always less than or equal to theta naught, that is right side. The alternative will be right side. If I say theta is greater than or equal to theta 0, that means it is left side. So this is the generally three types of alternate. H0 stands for, see the previous slide, it stands for null hypothesis, whereas H1 stands for alternative hypothesis. Now, to make you understand, when we reject the hypothesis, when we accept the hypothesis, I would like to talk about one small story. See, our normal BP should be, because you have a very nice Ayurvedic college, I was told by your Vice Chancellor, sir. So actually, our BP should be between 120 to 80. Suppose our BP rises to 85, we don't rush to a doctor. When do we rush to a doctor? We rush to a doctor when it deviates too much. Otherwise, we feel that I have a lot of workload, so my stress is increasing today. That's the reason my BP would have raised. By evening, your BP decreases because of the leisure time. Maybe because of this faculty development training program, your BP would be raising even now. Now I take up one small example to tell you how you reject the hypothesis or how you accept the hypothesis. Let us think that Butler is a person who was walking on the road. When he was walking early in the morning, he saw a dead body. He immediately reports the police. There could be 4 an innocent person, but the police arrest him. It's a wrong decision. The butler is an innocent person and police releases him. That is also a correct decision. Whereas an innocent person is being arrested, that is a wrong decision. So there could be 4 possibilities. A butler is accused by the detective and in fact he did it. That is a correct decision. A butler is accused by the detective when in fact he did not commit the crime. That is an incorrect decision. Similarly, butler is considered innocent and he in fact did not commit the crime. It is a right decision. Okay. Then the butler is considered innocent and in fact he did commit the crime. It is a wrong decision. I am putting it in a tabular form, which you will understand. Butler did it and the police charge him. It's a correct decision. Whereas butler did not do it and they release, that is also correct decision. But there are 2 correct decisions as well as 2 wrong decisions. We are talking about that. The hypothesis here and the alternative hypothesis, Butler is not innocent. Now let us convert this into our statistical things. In actual decision making, when it comes, for example, Butler, in actual situation, he is innocent and the judgment also has been given it as innocent, then it is correct. Where actually he is innocent, but the judgment says that he is a culprit, it is an error. Actual situation, he is a culprit, but judgment says he is an innocent and they release, that is a wrong decision. And here, actual situation, he is a culprit and they arrest him, it is a correct decision. Now we will go to the some medical terms. Actual situation, you have COVID. And diagnosis also, they say that COVID is positive. It is a correct decision. Suppose you are suffering from COVID, but the doctor says, no, it is negative for COVID. It is a wrong decision. Suppose you do not have COVID and the doctor identifies or he tells that it is positive, then it is a major problem and it is a major error and that is an error. And you don't have disease and doctor says, no, it is negative, that is a correct decision. So there could be 2 correct and 2 wrong decisions. To make you understand, I took up this example of cricket. Usually we see when we watch TV, we see that it goes to the 3rd umpire whenever there is a clarification. So what it does is, actual situation, a person is not out, but the umpire also tells he is not out, that is a correct decision. Actually he is not out, but umpire tells, 3rd umpire tells he is out, that is a wrong decision. And in actual situation, he is out, He's out. Sorry, 1 minute. Just a minute. He is actually out, and the umpire tells he's not out. That is wrong. Actually, he's out, and the umpire also tells he's out. That is a correct decision. And suppose you take up the quality control, you go and purchase mangoes from the slot. It is a bad lot you have, and the quality control also tells that those are bad mangoes. That's the correct decision. A good lot is there, but the quality control people say that is a bad lot. That is an error. Similarly, a bad lot, the quality control people certify that as good. That is also an error. Whereas a good lot being quality control certify it as correct, that is also correct. In research, when you convert these practical examples into research, actually research is not effective, but the decision you have taken as not effective, that is a correct decision. Suppose a not effective decision, you are converting that as a effective, that is an error. Similarly, an effective decision, you are converting it as not effective, that is also error. I hope you understand this. Now, suppose you take this and probability of committing this. Actually, when it is correct and we are rejecting the null hypothesis, that is known as the level of significance. Probability of committing this error is known as level of significance. Type 1 error means rejecting the null hypothesis when in fact it is true. And probability of committing type 1 error, we call it as risk or level of significance, alpha. 1 minus alpha is nothing but the confidence. Last class, when I was talking about SPSS, I told 95% and 5%. 5% is alpha and 95% is a level of significance. Similarly, type 2 error means accepting the null hypothesis when in fact it is false. And the power of the test is 1 minus beta. Actually, how to reduce this alpha and beta? By increasing the sample size. I think somebody might have told you they are inversely proportional. As the sample size increases, the error decreases. They are inversely proportional. Now, I have converted that into hypothesis, that is null hypothesis, when in fact it is. Hello? There is some background noise. Is there any problem? Hello? Gopal sir, is there any problem?
Yes, madam. Vikrant ji unmute हो गया था उनका, उन्होंने mute कर दिया. ठीक है.
Okay.
Now it is fine.
Okay, is it audible? Any problem? You can just raise your hand. If there is any problem, you can raise your hand and stop me. Okay. So, in fact, when the null hypothesis is true and we actually do not reject, means we accept it, it is a correct decision. When it is true and we are rejecting it, it is actually type 1 error, and probability of committing that is significance level. That is what is written in the thesis or any article. That is alpha. I'm stressing on that. I will not talk much about type 2 error. Now, this is actually, you can just see when it is in the graph, you can just see the concept of power and this, okay, the 1 minus beta. I'm not going in detail about this. Now, actually in hypothesis testing, we have so many steps. One is statement of hypothesis, then establish a level of significance. I told you for all field survey, we keep the risk or the level of significance at 5%. Then the rejection region will be there at the tail end. Then we have to either collect the data or sample analysis, or we have to conduct an experiment in the laboratory or in the field. Then we have to use proper statistical test. And finally, we have to make the decision. I'm going to talk about the decision. See, this is what we mean by two tail and one tail. One tail means only one end we have the critical region, whereas in two tail, we will have it in both ends. Suppose there is 5% is the level of significance, then 2.5 on the left-hand side and 2.5 on the right-hand side will be the rejection region or the level of significance. This is just to show you. I had the graph, so I just thought it will be clear to you. Reject two tail, or right tail means it is on the right hand side, left tail means it is on the left hand side. Okay. For example, I say that null hypothesis says that mean is always more than 3. Then it comes on the null hypothesis. Alternative hypothesis, mu is less than 3. That is at the left hand side. Suppose I say that mu is always less than 3 and the alternative hypothesis mu is greater than 3, that is on the right hand side. And suppose I say mu is not equal to 3, the alternative could be either less or on the right. So it is two tail, both ends. Is there any doubt till now? I shall go for the statistical test now and the interpretation. This is just a preliminary. Any doubts till now? Hello? Can anybody tell me? Hello? Is there any doubt? Gopal sir?
No, ma'am, continue.
Okay.
We understand.
Okay. When to use which statistical test, that is very important. Most of us get confused when to use which statistical test. Before that, you need to understand, I think Manjunath has already told you, nominal, ordinal, ratio, and interval scale. So depending on the data, we have to use a statistical test. We have 4: nominal, ordinal, interval, and ratio. In nominal, it is just name. It is the weakest of the scale. Data follows, for example, male and female. How many males are there? How many females are there? How many boys are there? How many girls are there? That is just nominal. Or the ID number, or the number given to this, Aadhaar card number. All this are nominal. Whereas ordinal means it is attribute can be ordered. Like we can say that assistant professor, associate professor, then professor. It is in the order. Assistant professor followed by associate, then professor, like that. The interval is, for example, the temperature. Okay, 30 to 40, 40 to 50, 50 to 60, like this. Interval is there. That is it. One interval is given. Then the ratio is all absolute zero, either area, production, or temperature, relative humidity, rainfall, all things. So usually we can use all statistical tests for interval and ratio, not for the nominal data. Now I have given in a summary what are the examples you can think of under nominal. It is gender, male or female, or vaccination, whether it is vaccinated, no, or not sure whether you are vaccinated or not. And the ordinal is excellent, very good, good, fair, or poor. Then last 30 days, whether you have used, never used, not in last 30 days, 1 to 2 days, like this in the order. Then the interval is body mass index. You know that obese, then the normal, and what do you call for the third one? It is very weak, like that. And the ratio, number of drinks, number of sexual partners, perception, blood alcohol concentration, and things like that. Now, we are using different tests: Z test, T test, F test, chi-square test, correlation, regression, one-way analysis, and two-way analysis and all. When to use which test? That is the next. All of us will be thinking when to use which test. Z test is used when the sample size is large. That means more than 30. If the sample size is more than 30, there are some other assumption also, like all the samples should be drawn from normal population. You need to understand the population variance. So if 3 conditions are satisfied, then we go for Z test. But suppose a sample size is small, but it is drawn from the normal population, you can go for T test. There we have 1 sample and 2 sample and p test. Then to compare the variances, last class somebody was asking what's the difference between T test and F test. T test is used to compare the means, whereas to compare the variances, we go for F test.
Oh, hello.
Yeah.
Ma'am,
Yeah,
exactly sample size is 30.
Yeah.
Exactly sample size is 30.
Yeah.
Which test we will use?
No, see, actually T approaches Z when the sample size is 30 and more. There is no harm. It is almost the same. Only the sample standard deviation we calculate in case of T. Otherwise, it is almost the same. So there is no, you might have seen in so many articles, even if the sample size is more than 30, 40, 50 and all, they write it as T. They don't write it write it as Z. T approaches Z when the sample size is 30 and above 30.
Okay, ma'am.
Okay.
Mm.
Any other question? Any other question till
No.
now? Okay. Then the Z test or the large sample test. Now I would like to show you the normal curve. This is a Z table. I do not know how many of you have seen this table. Actually, the Z covers, we are converting any variable into a standard normal variable, because otherwise to calculate the probability, we need to integrate. That is very, very complex. That's the reason, like logarithm and anti-logarithm, they have converted any variable into standard normal variable, which is unitless, and one table, ready-made table is given, which runs from -1 to +1, which is a symmetric curve. That means to say that suppose you fold it in the center at 0, that will be exactly the replica of the other. So you can see in the Z, 0.0, that is 0. So it runs from 0.0 to, yeah. Nishant, any problem? Nishant Yadav? You have any problem? Nishant?
No, ma'am.
Okay. No, I can see your voice talking. That's the reason. If you have any problem, you can stop me. So this is a table. You need to understand this table very clearly. This runs from 0 to 0.5 on the right hand side. Similarly, 0 to 0.5 on the left hand side. If you understand this table, you can just conclude that. Okay. I'll be directly going for the t-test. Actually, W.S. Gossett in the year 1908, he used to write the articles in the name of student because he was not very confident about his articles. That's the reason he used to write it as student. Later, it became so popular that everyone forget about his real name and it has become like student t-test. It is actually used to compare between the single sample against a population parameter, or to compare between the two groups, or to know the impact of certain drugs or any intervention. So there are three things. One is single sample, then independent sample t-test, and pay t-test. So I'll be talking about that. It is actually, the assumption should be population standard deviation is unknown. We are going to calculate, and the sample size from each population is small, that is up to 30. Then independent sample t-test or pay t-test. The application, you can, I have already told, you can compare the single mean versus the population, or the population variance being unknown, then there is a significance difference between the two sample means, where the population variance being equal and unknown, and testing the significance of observed sample correlation coefficient also we are using the same thing, t-test. Then testing the significance of observed sample regression coefficient also we are using this. Now, actually, the null hypothesis says that population mean and the sample mean are equal. Mu is equal to the mu hat, like this. And the sample statistic is T is equal to X bar minus mu, X bar minus mu, S by root N, where X is the sample mean, mu is population mean, S is the standard deviation, which we are going to calculate. And for two, you need not worry about the formula because you get ready-made computer output. So you need not worry about the formula. You just concentrate on when to use which test and how to interpret. And to compare between the two groups, we use two independent sample t-test. The formula is like this: X bar 1 minus X bar 2 divided by standard deviation. And one more thing, all of us need to understand, if the calculated t-value is less than the table t-value, that is a critical value, we accept the null hypothesis. Otherwise, we reject the null hypothesis. I was talking about BP. If it is beyond certain level, then only we rush to the doctor. Suppose our BP is supposed to be 80. If it is between 70 to 90, we don't rush to the doctor. Only if it is below 70 and above 90. So that 70 and 90 is known as a critical value. So each test has some critical value. That is depending on the degrees of freedom. The table critical value has been given. If the T calculated value is less than the critical value, or the table value, then we accept the null hypothesis, otherwise we reject the null hypothesis. If you remember this logic, then there is no confusion at all. I'll repeat once again. If the calculated value is less than the critical value, then we accept the null hypothesis. I feel today my BP is 85 because I have to give the guest lecture, that's okay. But if it goes beyond 90, then I reject my hypothesis. No, there is something wrong. So I rush to a doctor. So that critical boundary, what I feel is 70 to 90. The 70 and 90 are the critical values. If it is between this, I accept the null hypothesis. Otherwise, I reject the null hypothesis. Now, this is the T table. You can just see here. It is two-tailed. You can just see. You can just see here. When it comes, degrees of freedom, when it comes down, see, I told you it reaches 1.96. You can see when the degrees of freedom is 30 and above, it is 1.96. That is the table value of the Z. So somebody was asking when to use that. So 1.96 is the minimum value to reject the hypothesis. This is a T table. It goes on changing for different degrees of freedom. I hope you understand what is degrees of freedom. It is number of independent variables. Suppose there are 10 observations. All 9 will have the independence. The last one will not have. So 10 minus 1 will be the degrees of freedom when the sample size is 1. Suppose there are 2 samples, then it is n minus 1 plus n2 minus 1. That is n1 plus n2 minus 2. Now, see, the interpretation starts now. An experiment was conducted on agronomy farm at College of Agriculture to test the different types of grasses. There are 2 types of grasses, grass 1 and grass 2. Its yield per plot was collected. Weight of grasses per plot in kgs. So you can see there are 10 observations in the first grass type and there are 10 observations in the second grass type. One more thing I would like to say, whenever you are using the independent sample t-test, the sample size need not be equal. It could be unequal also. In this case, coincidentally it is equal, but it need not be equal. One could be 9, another could be 10. One could be 7, another could be 9, like that. It need not be equal. In this case, it is equal. So let us see how to interpret the results. Now, this is a result what we have. The mean of the grass 1 is 1.83 kgs. Mean of the grass 2 is 2.15. You feel that there is some difference. 1.83 and 2.15, there is some difference. Our null hypothesis what? The mean of the grass 1 is equal to mean of the grass 2. Do you reject the hypothesis or do you accept the hypothesis? That is our next question. You can just see we have mean, we have variance, we have observations, 10 observation in the first, 10 observation in the second, and the pooled variance. Whenever we are having 2 groups, we are combining the variance by testing the variance. So that is the pooled variance of the whole 20 observation. In this case, it is 0.01762. And we hypothesize mean difference means we always assume that there is no difference between the 2 populations. And the degrees of freedom, I told you, whenever there is 2 groups, it is n1 minus 1 plus n2 minus 1. So now 10 minus 1 plus 10 minus 1, that becomes 18 degrees of freedom. And the calculated t statistics in this case is minus 5.35. It is nothing but 1.832 minus 2.15 divided by its pooled standard deviation. Okay, so it is that. Now the critical value, table value is 2.100 and the probability or the level of risk is 4.31 into, you can just see here, there, E minus 0.05 is there. That is nothing but 4.31 into 10 raised to minus 5. So you can see in the bracket that is 0.00043. The level of significance is so low. We are ready to take the risk of 0.05. It is much beyond that. If you are getting confused, I told you if the calculated value is greater than the table value or the critical value, we reject the hypothesis. In this case, it is -5. Don't think of the sign here in case of t-test and z-test. -5, it is because 1.83 minus 2.15, it is a symmetric curve. So 5.35, is it greater than 2.10 or less than that? It is greater than 2.10. So with 95% confidence, or in this case, it is actually 1 minus 0.000043 into 100. So it is 99.99999957% confidence you can reject this hypothesis. What does it indicate? GRAS 2 yield is significantly superior compared to GRAS 1. With so much of confidence, you can say that there is a significant difference between the GRAS 1 and the GRAS 2, and GRAS 2 was found to be statistically superior over the GRAS 1 due to its higher yield. Is that clear? Hello? Hello? I want the feedback, otherwise one way is very boring.
Yes, ma'am, it is clear.
Yes, madam.
Is it clear? If the see, it is not only for t-test, any test, if the calculated value, in this case, the 5 points. 5.35 is 5.35 is the calculated value, whereas 2.10 is the critical value. If the calculated value is greater than the critical value, we reject the null hypothesis. It is beyond the boundary. Had it been within the boundary, we would have accepted this. Whatever difference is there, it is just due to the chance factor, not statistically significant. That is what you need to understand. Now I'll shift on to paired t-test. Okay. See, in this case, it is to test the intervention between one group, means before and later. Suppose you want to test the drugs given to the same individuals before as well as after giving the drug. Okay. See, I was telling in the last class itself, Gopalji should have given you one questionnaire in the beginning as well as later, and he would have tested your knowledge on statistics. That is paired t-test we have to use. Generally used when measurements are taken from the same subject before and after manipulation or the treatment. It can also be used to compare samples that are subjected to different conditions, provided the samples in each are identical. The assumptions means the same observation are not completely independent, but they are dependent in pairs. N1 is equal to N2, which is N. Then the standard deviation in the population are equal and not known. Differences of paired values is normally distributed. These are the assumptions. Now, here the null hypothesis says that mean before is equal to mean later, or the difference is 0. And this test statistics T is equal to absolute difference divided by standard deviation by square root of N. Don't by heart the formula, don't worry about this. Here, the difference is important. We assume that the mean difference before and later is 0. This is a main null hypothesis, what we have. And I told you already, if the calculated value is greater than the table value or the critical value for N minus 1 degrees of freedom, we reject the null hypothesis. If it is less, we accept the null hypothesis. Okay. So let us take one example only. This is actually the research topic which was conducted by our university student, PhD student, management of dairy farms during natural calamities. The study was conducted in 2 districts of North Karnataka by taking a sample of 120, 60 from each district. So totally it was consisting of 120, and purposive random sampling who were like from the farmers who have suffered the natural calamities were collected, and paired t-test was used on the socio-economic status of dairy farmers. You can just see the indicators: education status, social participation, type of house, asset position, farm position, fodder availability, borrowing status, access to basic need. These are the 8 indicators she has studied. And there are two types of natural calamities. One is flood and one is drought. Now you can see in Gujarat, it is heavy tsunami. Because of that, it is so many families have been affected. Similarly, in Karnataka, we are facing drought. So the in case you take the flood, she has collected information from 60 farmers. You can see the education status. There is no, the T value is 1.76, which is not significant. Any value below 1.96, it is no. If it is above 1.96, you have to think of the degrees of freedom and the table value. Then you can say social participation, yes. It has, before it was more, after flood, the social participation has decreased to the extent of 8.74, which is statistically significant. And type of house also, some of them have lost their house. 6.62 percentage change or percentage decrease is there, and the calculated T value is 3.01, which is highly significant. That means to say that after the flood, few people have significantly lost their houses. Then asset possession also, they have lost their asset also. 15.28% of decrease is there, which is also statistically significant, the T value being 5.26. Then you go for the farm power possession. See, the flood is mainly going to affect the farms. So there is a decrease of 41.16% after the flood, and it is also statistically significant. Then fodder availability also 62.36% decrease was found, and which is also highly statistically significant. And borrowing status, they used to borrow the money and all, but after the flood, because they were not having much farms, so the borrowing has reduced significantly, and it is evitable from T value, which is 4.85, which is significant. And access to basic needs, that is also like it is decreased because of the flood, they couldn't go out and they couldn't buy, which is also statistically significant. You can see, except education status, whether flood or without flood, their education status remains the same. All other things are statistically significant. Social participation, type of house, asset possession, farm power possession, fodder availability, borrowing status, and access to basic needs. And in case of farmers who are suffering from drought, you can just see education status here also. It is almost the same. Then it is not statistically significant. You can see, except fodder availability and access to basic needs, all other things during drought remain the same. Not much variation is there. There is slight decrease, but not statistically significant. Is that clear? Any doubts in this table? Hello? I shall move on to the next table. Now, the second example is the effect of COVID-19 on women entrepreneurs engaged in Mithila painting. Okay, this is a study conducted by Aparna Kumari in Madhubani district of Bihar. 60 women entrepreneurs have been selected during COVID-19. Purposive sampling method and paid test was used to find out significant differences in the socioeconomic status of women entrepreneurs before and during the pandemic crisis. And you can just see the main occupation before, so many, like it was 4. 5-point scale was used. So 4, it has reduced to 2.733. You can say that occupation has been really damaged. There is a significant difference in the main occupation. Suppose they were doing actually engaged in Mithila painting, that has reduced drastically, and T value being 8.44 is significant. And in the subsidiary occupation also, it is affected, which is T value is 3.43. You can say that after COVID, their main occupation as well as subsidiary occupation has been affected significantly, and statistically it is significant. And source of information used by respondent before and during COVID, you can just see before and during COVID, radio, that is, they used to have before, but they switched on to radio because during COVID, they could not go out. They used to either listen to radio or watch television or usage of mobile then newspaper and farm magazine, which all have been increased. Their occupation has decreased because they used to sit at home only, they could not go out, they could not do anything because of COVID. But use of all this media like radio, television, mobile, newspaper, farm size, all this have been increased. You can look into the T value 4.03, 3.01. So you can say that during COVID, they used to sit at home and use all this social media like radio, television, mobile, newspaper, even the ladies, which is highly significant. Then differences in ownership of fixed and farm asset before and during COVID-19. If you take up the land holding, housing, there is absolutely no changes because land holding remains the same. Housing also remains the same. Livestock ownership, dwelling for livestock also remains the same. But livestock ownership, it has decreased. They might have lost the livestock during COVID. So it has drastically reduced, and the T value being significant 2.081, you can say that during COVID, they have lost their livestock. So also the farm asset, they have lost farm asset, which is 2.4 to 1.68, it has reduced during COVID, and statistically it is significant 3.287 is a T value. Any doubts on this? Any doubts? Hello? Hello?
No, ma'am.
Okay.
No, ma'am.
Okay. Then the third case study, next case study is agroeconomic impact of climate resilient practices on farm, Anantapur district of Andhra Pradesh. It is a study conducted by Hari Krishna et al. In the year 2019. You know, in Andhra Pradesh, there is a district called Anantapur district. 60 respondents were selected purposively, and b.ed was used to study the impact of climate resilient practices on area under irrigation, crop yield, cropping intensity, and annual income of the farmers. Now, these are the 4 indicators before and after. You can just see they had 1.05 area before adoption, and after adoption, it has increased. So you can say that because of the adoption of climate resilient technologies, their area under irrigation has increased drastically, which is statistically significant by 11.56 is a T value. You can see there is 59.04% change in the area under irrigation. Farmers have shifted themselves into the area and they were using irrigation. When it comes to crop yield also, from 1.92 tons per hectare has enhanced to 2.50 tons per hectare. There is a percentage change of 30.06, and T value is highly significant, that is 29.77. So the crop yield also increased because area under irrigation had enhanced drastically. Then the cropping intensity. You know what is cropping intensity because you are not agriculture. Maybe there is one discipline. Cropping intensities, the crops grown. For example, you have 1 acre land. Suppose you are growing in Kharif, again in the Rabi, if you are growing, that becomes 2 crops you are growing. Then even in summer. So the intensity of crop, what is grown in the same land is known as cropping intensity. So it has increased 98.43 to 139.37. There is a percentage increase of 41.59. That is also statistically significant. Because of climate resilient, they started adopting irrigation, then the yield also increased, cropping intensity also increased, and obviously when the yield is increased, annual income also has to increase. Earlier they used to get actually 57,733.33 rupees per acre, whereas it has shifted to 9,520.08 rupees per acre or whatever it is. So there is an increase of 56.78% of annual income, which is statistically significant. This is a very good study, and because of climate resilient technologies, what they have adopted, their income has been almost increased to not double, but at least increased to 56.78%. This is about t-test and p-test. Now I'm shifting to chi-square test. Is there any doubt under independent sample t-test and chi-square test? P-test? Any? I'll stop after each test for 1 minute. You can ask or raise hand and ask any questions if you have. Hello? Hello, any doubts? Any doubts? Gopalji? Any doubts? Now I'll go for the chi-square test. Actually, see, t-test, we are comparing the means. Now, chi-square test was developed by Carl Pearson, which is used to measure the differences between what is observed and expected. It is known as non-parametric test actually. There is no assumption which is there. It is a non-parametric test, not based on any assumption or distribution of any variable. This test can be applied to a complex contingency table with several classes and such as very useful test in research work. Usually, those of you who do not follow any parametric test, you can go for this. The assumptions of chi-square test are both variables are categorical. Then the data in the cell should be frequencies or counts of cases rather than percentages. Then the categories of the variable should be mutually exclusive. And the expected value of each cell should be 5 or more than that. And all observations are independent. And sample size should be considerably large, usually greater than 50 VC. Then the application, it can test. It can be used to goodness of fit of distribution, then test of independence of attributes, and test of homogeneity. It can be used for all these three. I'll be talking about test of goodness of fit of distribution. This chi-square, you can just see, it enables to see how well the assumed theoretical distributions such as binomial or Poisson distribution fit to the observed data. Chi-square test, see, it is observed minus expected whole square divided by expected. When you sum all this, that is the chi-square. If the calculated chi-square, the logic is same. If the calculated chi-square is greater than the table or the critical with n minus 1 degrees of freedom, then the null hypothesis is rejected, else it is accepted. Okay, so we shall take up test of that is a test of goodness of fit. Then comes a test of independence. That is two variables are there, categorical variables. One is put in the columns, another one is put in the rows. So we would like to know whether there is any association or the relationship between the categorical variables. The null hypothesis says that two attributes are independent of each other, whereas the alternative hypothesis says there is significant association between the two attributes. And the same thing, logic. If the calculated chi-square value is greater than the table or the critical value at a certain level, means 5% I'm talking about in general, for a given degrees of freedom, then the null hypothesis is rejected, else it is accepted. Then the test of homogeneity, that is a third test. I don't think you will be using this. However, I'm just talking about this. You have a variety of uniformity of the events. Then what you do is, for example, the admission of patients in government hospital in all days of week is uniform or not, can be tested with the help of chi-square test. Here also the logic is same. If the calculated is greater than the tabulated, then the null hypothesis is rejected, otherwise it is accepted. So let us go to the example, that is analysis of socio-economic status of farmers in the southern dry zone of Karnataka. Umesh et al. In the year 2022 has conducted this. Yes, any doubt? Hello? Chat box, no, chat box. Can I continue? There is some disturbance again. Hello? Okay. Now, the study was carried out to know if there was any association between the socio-economic status of farmers and education level in selected districts of Karnataka. Then the primary data related to details on socio-economic characteristic features, input use pattern, and education level of the farmers, which was collected by personal interview using the pre-tested schedules. You know, you have to prepare the schedule and then only go for primary data collection. And multi-stage random sampling, means not one stage, a two-stage sampling was used. And chi-square test was used to examine the degree of association between the socioeconomic status of farmers and their education level. So if you see the table here, one side we have education level, another side we have socioeconomic status. That is below poverty line, BPL and APL, above poverty and below. Our assumption says that there is the socioeconomic status or the income and the education level are independent of each other. That is a null hypothesis. The alternative hypothesis says that no, the education level is dependent on the socioeconomic status. They are dependent on each other. Here you can see we have only frequency. We don't have any mean or variance or standard deviation or anything. It is only the percentage. And the chi-square value is 9.78, which is significant. Star mark indicates significant at 5% probability level. You can just see here, more of the illiterates belong to below poverty line. The illiterates cannot afford and they are illiterates. Below poverty line people are illiterates, whereas above poverty line people are above the secondary level of education, at least they have in the villages. 84.61% of the people have gone to schools and they have. I think I request the participant to kindly mute. If you have doubts only, you please ask me. Otherwise, it is a disturbance from your side. Gopal sir?
Yes, madam.
Kindly instruct your, kindly mute others because there is some disturbance.
Okay,
if
madam.
you have doubts,
Yes,
they can
please.
ask. Not otherwise.
Sure, madam.
Okay, please. So actually, this table is very important. Once you understand this, okay. Now, you can see from this table that above poverty line, they are either up to the secondary level or above the secondary level. They are educated. Whereas the below poverty line people, most of them, 65%, are uneducated. That means to say that there is an association between education and socioeconomic status, and chi-square is also significant. That is evident from chi-square, which is significant. So they are dependent on each other. Education level is dependent on socioeconomic status.
Hello,
Then-
ma'am.
Yeah, please.
In previous slide, the percentage change. How you calculate?
Which percentage? This percentage.
65% that is used by using overall row total.
Yeah,
Row total.
Dikeshwar, actually the null hypothesis here says that the education level and the poverty or the socioeconomic status are independent of each other. Suppose they are independent, then it should have been, the percentage should have been 50-50. 50-50. Whether they're above poverty line or below poverty line, they should have been 50-50, isn't it?
Yes, ma'am.
Now, the below poverty line is 65%, whereas above poverty line is 35%. They are more towards illiterates. So below poverty line people are not able to spend and go to school. And here the chi-square is significant. 9.78 is significant. Actually, the row -1 into column -1 is the degrees of freedom. So at 2 degrees of freedom, the table value is 7.89 or so. That's the reason it is significant at 5%. Now, if you see the above the secondary, out of 13, 11 people are above poverty line. That means to say that above poverty line people could spend and go to school and educate themselves above the secondary level. With the help of this percentage, I'm explaining. Any doubts?
Okay, ma'am.
Okay, Dikeshwar, is it clear?
Yes, ma'am.
Okay, and overall also, if you take above poverty line people, percentage is more compared to below poverty line. So education level is dependent on the socioeconomic status. Okay. Then calculated chi-square value, which I have already explained, for the socioeconomic status of the farmers was greater than the chi-square table value, which is 5.99 at 5% probability level. This higher value of calculated chi-square suggests rejection of the null hypothesis, which I have already explained. We shall go to the next. That is yield gap analysis of selected crops in southern dry zones of Karnataka. This is in Karnataka. Usha et al. Has studied this in the year 2020. The study districts where she has selected crops like, I think 2 crops she has selected, ragi and sugarcane. And dry zone of Karnataka she has selected, which is the leading district, Tumkur district for ragi and Mandya district for sugarcane. 2 district main crops have been selected from that. And she's collected data of the weather, area production and productivity from Directorate of Economics. I think even you have that directorate in UP, so you get the secondary data, but she has used the primary data also to study the socio-economic characteristics. Then the present study used multi-stage random, that is not 1 stage, 2 stage or 3 stage, we call it as multi-stage, and chi-square was used. This is a table, age group versus yield. The null hypothesis says that the age group and yield of crop are independent of each other. Now the chi-square is not significant. Here, 2 into 1, again the table value should have been 5.99, the critical value. Now it is less than the table value or the critical value, 2.84. So we say that there is no association between the age group. Whatever may be their age, the yield is not going to affect. They are independent of each other. You can see even with the percentage also, maybe you might ask average, above average yield, less than 35 years. In this case, whatever difference we are finding out, it is just due to chance factor, just by the sample difference. That's all. It is not statistically significant. Okay, shall I move on to the next? Then the age group versus sugarcane, just similar to ragi, they have tried with sugarcane crop also. Here also there is no association between the age group and the sugarcane yield. So chi-square was found to be not significant also. Both ragi and sugarcane, the calculated chi-square value was 2.84 and 2.07 respectively. These values are lesser than the chi-square table value or the critical value. So that by suggesting that you can accept the null hypothesis, there is no association between the age and the yield level of the sample farmers of both the crop. Any doubts in this chi-square? Any doubts in this? Any doubts? Any doubts? Can I move to the next test? Hello?
Yes, ma'am.
Okay. Now I'll be talking about the correlation. I think last class, time when I was talking about correlation, it is the relationship between 2 or more variables. I told you 2 individuals also, we have 3 types of relationship. One is positive, one is negative, enemies, or no relationship. Same thing with the variables also. It is an analysis deals with the association between 2 or more variables that are, those are quantitative variables. Okay, so correlation analysis attempts to determine the degree of relationship between the variables. If the change in one variable affects a change in the other variable, the variables are said to be correlated. It measures the association between the 2 variables, but here the variables are quantitative. It is in ratio scale, not in nominal scale. Whereas attributes in chi-square, the scale, it could be attributes or frequencies. But here it should be in the ratio scale. And the coefficient of value varies between -1 to +1. If it is +1, we say that positive relationship. If it is -1 or nearer to minus, we say that inverse relationship or negative relationship. Then there are different types of correlation. One is simple, then partial and multiple correlation. Then the simple correlation, I'm talking only about simple correlation in this session. This is a formula. Please don't worry about the formula. It is a covariance between the two variables divided by its standard deviation. The sign depends between the covariances. To give you one example, there are two students in the class, X and Y. X alone is very good. Y alone is very good. But when they combine together, it could be negative. We do not know. That is what we mean by covariance. The variation between X and Y. The just standard deviation means only the X alone. Standard deviation of Y means the variance of Y alone. In the class, you all are teachers, you might have observed, when you talk about one individual person, they are very good, but in a group, they behave differently, negatively. That is what is covariance. Then which method of correlation to use? You can either use a mathematical formula or even to the graph also you can use it. That's the reason I've taken up this slide. That is the calories per day. The more we eat, the weight increases. You can just see here, suppose you take only 1,000 calories, then 2,000 calories, only your weight will be 150 pounds. Suppose you increase it 3,000, 4,000, 5,000 like that. As the calories per day increases, your weight also goes on increasing. I don't know whether it's statistically significant or not, but there is an upward movement. These two are moving in the same direction. There is a positive correlation between the calories per day and the weight of the person. Now, suppose all of us are quite conscious about our weight and health, and you have Ayurvedic, very big institute also. So minutes of exercise per day and the weight. Suppose you exercise more, your weight will decrease. They are moving in the opposite direction. The more exercise, your weight is reduced. Suppose you are 150 pounds. When you are we are exercising 80 minutes or something like that, suppose you goes on increasing, your weight also drastically decreases. So there is a negative correlation between the exercise and the weight. They are moving in the opposite direction. Then, for example, the ice cream parlor in America and the person getting weight in Sanskriti University, is there any relationship? There are so many ice cream parlors in America, and the people who are getting weight in Sanskriti University or US Harvard, there is no correlation. It is random. Like here. You can just see there are so many scattered points. There is no correlation. Suppose you have so many ice cream parlors or fast food centers in Sanskriti University and student getting weight, there could be a positive correlation. But a parlor or the fast food centers in Delhi and people getting weight in Sanskriti, they are independent of each other. That is what it shows. This chart shows no correlation or zero correlation. So this is a figure. You can just see whenever positive correlation is there, upward movement is there. Whenever negative correlation is there, the downward movement is there. And R is nothing but the correlation coefficient. You can just see less than 0. Then no correlation, it is scattered. So R is tending to 0. There are three types of correlation: positive, negative, and no correlation. Positive is more than 0, negative is less than 0, and no correlation is equal to 0. And there are so many mathematical models. I'm not going for all the models, only Carl Pearson product moment. I'm just going for this. Okay. This is the, already I told you, this is the covariance between XY divided by standard deviation of X into standard deviation of Y. Kindly don't worry about the formula. You get the result directly. Those of you who are not very good, I can just say that R, if R is +1, it is perfect positive correlation. If R is -1, it is perfect negative correlation. R is 0, it is no correlation. It is a unitless measure which runs from -1 to +1. And actually, as a statistician, I can say that it can be divided into 5 parts. If it is between 0 to 0.2, either plus or minus. I'm not only talking about plus, it could be minus also, very weak correlation. Correlation is there, but it is very weak. 0.2 to 0.4, it is weak. Then 0.4 to 0.6, moderate. 0.6 to 0.8 strong, and 0.8 to 1 very strong. But this is just a thumb rule. This is just a logic. It varies with the sample size. As the sample size increases, even if the correlation coefficient is less, it could be significant. In this case, the sample size increases. If the sample size increases, even if the correlation coefficient is less, it can be significant. Okay. Now we have taken one example, the coefficient of correlation from the following study, where the number of study hours and marks scored in exam. You all know that if you study well, you get good marks. So these are the data what we have. If you study 1 hour per day, you get 9 marks. If you study 9 hours per day, you get 15 marks. So this is the juggleries what we have. I'm not going for this juggleries. So in this case, the correlation coefficient is 0.95. So there is a strong positive correlation between the study hours and person getting marks. These two variables are positively related. Now I'll give you the some examples later. I'm just going to the theoretical part first and go to the case studies. Then you have a regression analysis. That is, you can predict a dependent variable based on an independent variable. Y is a function of x. A plus bx plus e. Why I'm saying is error is a part. Whether I predict that Sanskriti University students should get 90 marks out of 100, but they may not get. This is my prediction. They may get 89 or 91, that is error. The difference between my expectation and their real is error. That is the reason y is a function of a plus bx plus c. Okay, so it lies between minus infinity to plus infinity. Here b is the regression coefficient. And types of regression, you have simple regression, means only one independent variable, or you can have a number of independent variables, that is multiple regression. Then the assumption, it should be normal, it should be independent and equal standard error. I told you already the equation y is a function of alpha plus beta x plus e, where y is a dependent variable which is dependent on independent variable, and a is a constant or intercept, and beta is the regression coefficient. Now we shall go for the formula. Again, covariance of xy divided by variance of x. And you can calculate a also by using this formula. The properties, you don't bother about the properties. I'll straight away go for one example. It is actually the agriculture example, the height of the soybean plant and their age. At 1 week, the height of the plant is 6 centimeter. After 2 weeks, it is 13 centimeter. After 3 weeks, it is 16. After 4 weeks, it is 23. After 5 weeks, it is 33. After 6 weeks, it is 38. After 7 weeks, it is 40. Okay, so I'm trying to fit a regression equation. I have calculation part. Don't worry how to interpret. Only you please worry about this. Now the regression coefficient is 6.03 and a is 0.0t. This is the equation. The height of the soybean plant is 0.02 plus 6.03 into x, where x is the age of the plant. For every 1 week, the plant is going to increase by 6.03 centimeter. Per unit change in x will change 6.03 unit of change in y. I don't know which unit they have used. I'm just telling you, per unit change in x will bring about 6.03 unit change in y. You can predict this. I'm going for the case study so that it will be clear to you. Actually, the epidemiology and management of common rust of maize, again, it is an agriculture example, in the Kusinia Sorgi Chew, which is conducted by Yalla Reddy in the year 2016, weather parameters and the rust of a crop. Rust is one disease in a maize crop. Okay. So these are the weather month, date, then age, weather parameters are there. I'm straight away going for the correlation coefficient. You can just say maximum temperature, minimum temperature, relative humidity in the morning, relative humidity in the evening, and cumulative. You can see that only 2 weather parameters are influencing, statistically significant, minimum temperature and the cumulative rainfall. That means to say that there is a positive impact of rainfall. As the rainfall increases, the rust disease also increases. It is statistically significant. Similarly, the temperature has a negative impact on common rust of maize. That is, as the temperature decreases, the rust increases. They are inversely proportional, minimum temperature and rust. The other parameters, if you take the relative humidity in the morning and the relative humidity in the evening, it has nothing to do with the rust. Only the rainfall and the temperature has an effect. Rainfall is positively influencing. As the rainfall increases, quite obvious, temperature is increasing negatively, which is significant at 1%. That means to say that with 99% confidence, I can say that the cumulative rainfall has a positive impact and the minimum temperature has a negative impact on the disease of the maize, rust disease of maize. Then the multiple linear regression, y is a function of simple regression is also there, multiple is also there. Now you can see that there are the same example, maximum temperature, minimum temperature, relative humidity in the evening, and this. Here, y is a function of x1, x2, x3, x4, x5. You can just see that. But the second doesn't have anything. You just see. Then going to the next, that is bean angular leaf spot. This is also another agriculture example. Don't feel you can correlate yourself to the medical field. Since I got many agriculture example, I have directly copied from that. In this case, the bean angular leaf spot caused by one disease, don't bother about that. First study to know about its occurrence, epidemiology, and yield loss. You know that whenever it is affected by some disease, there will be loss of yield. And the weather parameter also has been taken up and the regression was carried out. You can just see here, these are the disease incidence, disease intensity, and weather factors, the average temperature, rainfall, and the relative humidity. Now, if you see the table, the disease intensity and disease incidence, it is positively correlated. If there is disease, the disease intensity increases. They are moving in the same direction. If there is relative humidity increase, then also there is more of disease. See, whenever we have a rainfall also, the more rainfall always enhances the disease. You can just see that. So relative humidity and rainfall are positively correlated to the disease intensity as well as disease incidence, whereas temperature is not significant in this case. And relative humidity and rainfall, they are also positively. Actually, I didn't talk about path analysis. Path analysis is used for the indirect effect. See, temperature and rainfall are positively correlated, negatively correlated, you know, but relative humidity is also indirectly talking about that. I'm not going very deep into that because that again will take 1 hour to talk about path analysis. Now you can, for the same thing, you can see the regression equation first for the disease incidence and second for the disease intensity. Here the R square is 82.50. That means to say that 82.50% of the variation of the dependent variable is being explained by x1, x2, and x3. Whereas in the second case, R square is higher compared to first case. That is, disease intensity is increased. That is 86.01% of the disease intensity is explained by mean air temperature, average relative humidity, and cumulative rainfall. And last class, somebody was asking about R square and adjusted R square difference. I don't know whether they are there as a participant. R square, both are percentage contribution only. Only the adjusted R square, it improves. It actually improves the prediction and it improves. It clearly tells you the fit by adding some variables. The R square talks about the fit only, but adjusted R square, as you go on adding some variables, it tells you exactly whether it fits, whether there is an improvement. And adjusted R square will always be higher than the R square. There will be at least some 1 or 2 difference will be there, or 0.1 or 0.2 difference will be there. Is there any doubt till now? Hello? Hello? I cannot see the chat box also. Any doubts? Hello? Hello? Any doubts? Can I continue?
Yes, madam. Actually, I have not seen any doubt.
No. Participant side, any doubts? No, yes, madam. Somebody said, Ashutosh, you have any doubt? Ashutosh, you have any doubt?
No, ma'am, no doubt.
No doubt. Okay. Now we'll go for design of experiment. Actually, in design of experiment, we always talk about one-way analysis and two-way analysis of variance, or CRD and RCD. Before going for that, we need to understand the basic principles of experimental design. One is replication, another one is randomization, the third one is local control. The replication means repetition of an experiment. Repetition of an experiment under identical conditions. Suppose you are repeating an experiment in Sanskriti University one campus, and in the second campus, all measures should be taken care. Identical. Temperature should be same, relative humidity should be same, all ingredients should be same. That is what is replication, repeating under identical condition. Then randomization means you are giving equal opportunity for all the treatments. You are not biased. You are giving equal probability for each and every plot, suppose in agriculture, or each and every student. Suppose you are selecting the student. That is what is either you can use a lottery method, or random tables are useful. You can use a random table also. And the third one, which is important, is local control. You have to control all the variables except the one which you are testing. Suppose you are testing the one drug. Only drug should vary. Drug 1 and drug 2. All other parameters should be same. So these three are the basic principles to decrease the error. Error is a component of this designs. You know that we cannot decrease that by keeping all these three balanced: replication, randomization, and local control. All these three basic principles are used to reduce the error. This is again the Fisher. R.A. Fisher is the person who has found out this. Steps involved in design of experiment. One is formulate any research problem, then prepare the design, either selection of factors or levels, then layouting, allocation and arrangement, then collection, recording of the data, then statistical analysis of the data, and derive conclusion and write valid inferences. Now, this is a completely randomized design. This is usually used under laboratory condition. One of the assumptions is all the units are homogeneous. You can see you cannot control in the outside field, only in the laboratory. Like in biotechnology, you can control. In the medical lab, you can control. In the greenhouse, you can control. You can see these pictures. All this are used in agriculture under the greenhouse or biotechnology or medical hospital, like that, where all the what do you say, the units are homogeneous. Then we go for completely randomized design. The main assumption is that. So the basic, it is single factor, means only one side we are testing the treatment. That's all. When the treatments are assigned completely at random, and so that each treatment unit has the same chance of receiving any one treatment. I told you already. The advantage is very easy and simple to calculate, then provides maximum number of degrees of freedom for the error. It is disadvantage is less accurate than the other design like RCPD and things like that, and it increased experimental error and reduced precision. Now here, criteria for designing is experimental units are either plots or the patients or this should be homogeneous and used in case of pot experiment or lab condition. Even in Ayurvedic medical, you can use if all the units are homogeneous. Then the other two application, that is replication and randomization, should be done properly. Now, how to lay out the CRD? Just see the placement of the treatment on the experimental units along with the arrangement of the experimental unit is known as the laying out of an experiment. You can just see, suppose there are T treatments, let's say 10 treatments which are replicated 3 times. How to do that? So we need to have totally T into R experimental plots or experimental units, 30, let us see. Okay, so this is T into R1, R2, like that. In this case, you can just see there are 20 units. 20 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It could be student, it could be anything. Plots. Then 11, 12, 13, 14, 15, 16, 17, 18. How do we allot the treatment? See, T1 could be allotted anywhere. It is actually 5 treatments have been tried 5 times. 5 treatments have been tried 5 times. T1 could be allotted anywhere. You can see in the second row, it is allotted nearby. T1 and T1. 9th plot also it is there. 10th plot also it is there. First, you allot the T1 anywhere 5 times. It has gone randomly to 4th plot, 9th plot, 10th plot, then 18th plot. 4 times it has been repeated. So 4th plot, 9th plot, 10th plot, and 18th plot. Similarly, T2, you can just see T2 has been allotted to 7th plot, 13th plot, 14th plot, and 19th plot. T3 has been allotted to 2nd plot, 5th plot, 8th plot, 6th plot. T5 to 11th plot, 20th plot, 17th, and 16th plot. So it can go anywhere because all the plots are, units are homogeneous. It is repeated 4 times. Now, actually, Yij, I do not know how many of you will understand. Overall observed value is a combination of overall mean plus the treatment effect plus error. See, suppose you repeat an experiment, you get the same observation, we don't get the same observation. So it is the error, what we have. The overall mean is the expected mean. Now, this is one layout of this. Here, the grand total of all the observation. We shall take up one example. These are the steps. One is correction factor, then total sum of squares, then the treatment sum of squares, and error sum of squares. The results in ANOVA are summarized as follows. These are the fixed dummy table. One is source of variation, second one is degrees of freedom, third one is sum of squares, and fourth one is mean sum of squares, and F. The table F will not be there, but I have put it there to make you understand. Now the source of variation, total variation. That is totally in the experiment, what is the variation? Then the treatment variation. That is between the treatment, what is the variation? The error is the one within the treatment. See, suppose, for example, all of us cook. We will not get the same taste daily. Today, the preparation of tea will be different from tomorrow's preparation. Why that happens, we do not know. That is only God knows. That is a random error, which is a part and parcel of our experiment. That is known as the error, the random error. Suppose I prepare some tea, Gopalji prepares one more tea. Maybe Gopalji prepares very well. So that is between the individual, that is different. That is known as treatment error. Between the individual or between the variety, between the treatment. That could be accountable, but within the person is unaccountable. You take up any plant. One day you get 10 flowers, next day you may get 9 flowers, the third day you may get 8 flowers. Why this happens? The same land is there, same water is being given, but why does it flower differently? That is, we do not know that. That is a random error. One day it is flowering 10 roses per plant. Next day it is 9 roses. Third day it could be 8 roses. That is the error. Then coming to the degrees of freedom, I told you number of independent variables. Suppose there are n plots, altogether 20 plots we had. So 20 minus 1 will be the degrees of freedom. And we had 5 treatments. So 5 treatments. So it is 5 minus 1. 4 is the degrees of freedom for treatment. Then error is n minus t. That is 19 minus 4, that is 50. And TSS stands for total sum of squares. ESS stands for error sum of squares. Small TSS stands for treatment sum of squares. And we need to calculate the mean sum of squares, that is divided by respect to degrees of freedom. And here F is tested. The variances have been tested. Always we put F table. Somebody asked me last class, what is the difference? See, ANOVA, we are using F to know the difference between the variances, whether treatment variance and error variance, that is difference. Treatment is expected to be higher compared to the error. So treatment variance divided by error variance. And you, this is a calculated F value, you test against the table F value and you will get to know. If the table F value is greater than the table F value, then we reject the null hypothesis. Otherwise, we accept the null hypothesis. Here, the null hypothesis, all the 5 treatments are on par with each other. Then the next step, once the F is significant, then we would like to know which particular treatment is better and which one is not better. Here we have taken one example. 7 varieties of maize experiment was conducted in the greenhouse using CRD with 3 application. Solve the problem and draw valid conclusion. See, the grand total, everything is there. Now the calculated F value is 5.01. Whereas a table F value is 2.84. What does it mean? If the calculated is greater than the table, we reject the null hypothesis. That means to say that this 7 varieties differ. All 7 are not equal. My null hypothesis says that T1 mean is equal to T2 mean, T3 mean, T4 mean, T5 mean, and T6 mean, and T7 mean, but they are not equal. Now the next question tells which variety is better, which one is better, which one is poor. So the next one, you can just see here, the mean value, the T5 is 17.23 kgs per plot, whereas T1 is yielding 12.34. Whether all the 5 differ with each other or only one differs or second differs, we want to know. For this, we are using the critical difference. There is some formula for that. No, don't scratch your head. It is actually the table T value multiplied by the standard error between the means. So in this case, the critical value is 2.13. That is the yardstick used to compare between any 2 means. If any 2 means is greater than critical value, critical difference, we say that there is a significant difference. Otherwise, we say that they're on par with each other. When you compare T1 and T2, the difference is 2.5, which is higher than the critical difference. Then we say that there is a significant difference between T1 and T2. Whereas T1 and T3, if you compare, the difference is hardly 0.9. So T1 and T3 treatments are on par with each other. Statistically, it is not significant. Only T1 differs from T2, T1 differs from T4, T1 differs from T5. You can just see. But T1 and T3 are on par with each other. Similarly, T2 and T3 are on par with each other. They are not statistically significant. Whatever difference is there, it is just due to chance factor. Similarly, T2 and T4 are also on par with each other. Whereas T2 and T5 differs, T2 and T3 and T4 differs, T3 and T5 differs, T4 and T5. In a nutshell, T5 differs significantly from, except T4, it differs from all other treatments. Suppose you are supposed to say which variety is performing better, we can say that statistically T5 is performing excellent, significantly superior compared to T1, T2, and T3, but not from T4. Suppose the cost of cultivation is less for T4, you can select T1, T4 because they are almost similar to each other. Statistically, it is not significant. T4 is on par with T5. Is that clear? Any difficulty, you can ask me, please. I'll stop for 1 minute. You can ask if there is any difference, any difficulty. Any?
I have one.
Yeah.
Hello.
Please. Yeah, please.
I have one question, ma'am.
Yeah, please.
Regarding this degrees of freedom.
Okay.
It is little bit confusing for me. Can you give me an example? How I will be able to understand that?
Okay. See, we have treatment, we have replications. Okay. You have tried 5 drugs. 5 drugs. Let us say you are which field you are in? Which field you are from?
Ma'am, I'm from agriculture.
You are from agriculture. So suppose
Yes.
you are comparing 7 varieties. 7 varieties. Hello?
Yes, ma'am. Yes, ma'am.
Yeah, you are comparing 7 varieties in 3 replications. So totally there will be 21 plots required for you. Okay?
Okay, ma'am.
7 into 3, that is 21. Homogeneous plots.
Yes,
So
yes, ma'am.
total degrees of freedom will be 21 minus 1, that is 20. Okay?
Ma'am, in this case, why we always -1 क्यों करते हैं?
That is what I said, number of independent variables.
Yes.
See, I'll give you one very simple example. There are 5 chairs and 5 students are entering the class. The first person can have the freedom of sitting in any of the 5 chairs. He has full freedom. Okay. The second one person sat there. Next, the 4 people are there. 4 chairs are there. The second person enter. He also has the liberty to sit on any of the things. Third person also has. Fourth person also. What about the 5th person? He doesn't have the freedom to sit on any chairs. He has to sit on that. So actually, summation of x minus x bar is always 0. You know that the
Yes,
error
ma'am.
difference from
Yes.
this should be 0.
Okay,
So the last person has to make it up so that the summation of that becomes 0.
Yes,
He
ma'am.
doesn't have freedom. The last treatment doesn't have freedom because it has to be like that. Okay.
Okay, ma'am.
Any other doubts? Can I move on to the next, or you want treatment error also like that?
Ma'am,
Hello?
in this, hello?
Yeah.
Ma'am, I was working on one of the projects in which part of my work was in the lab and part of in the field. Then would have suited that. As part of lab, it is CRD.
Okay.
But other part of my work is that from the field. Like
Field.
that, I am supplying something input from the field to the treatments in my lab.
Yeah. In the field, you have used RCBD, I guess. Hello.
Hello.
In the field, which experiment have you conducted? You have used CRD or RCBD? 2-way analysis or 1-way analysis? Hello.
2-way analysis.
Yeah, that is what. So you have taken a part of it and conducted the same experiment in the lab to test the efficacy of that, right?
Yes.
Suppose in the lab, everything has been kept homogeneous, then you can use CRD. There is nothing wrong in that.
Okay,
have you maintained all the local control under your control?
Yes, ma'am. Temperature, humidity, then timing of my
in the field, you would have got treatment as significant. Even the blocks also would have been significant. But to test some treatments, may not be all the treatments, you would have brought it to the lab and trying further, right?
Yes, ma'am.
Yeah, and then you can use CRD, but see that all the conditions are homogeneous within that. You are, while allotting the treatment, everything should be having the equal chance of getting into the plots or the units.
Yes,
okay?
yes, ma'am.
Any other doubt?
No, ma'am.
Madam, I have one.
Yeah, please. Please.
In previous slide, I have observed age group and yield of ragi. There is significant
chi-square. You are talking about chi-square. Yes.
Madam, in same way, I have some one doubt, madam, in one table. The quantity of fertilizers in kg per house by the sample farmers, semi-arid and coastal zone, and the dependent variable is experience of farmers, 25 years to 35 years
25 years, they have used F test and T value, madam. How we can understand this one?
No, I'm getting confused. I have never shown you the fertilizer. It is your case you are talking about, Suraj?
Yes, madam, correct.
Suraj,
Yes, madam. Yes,
fertilizer. 1 minute. Suraj, fertilizer is a quantitative variable. Have you
Yes,
made
madam.
it? Have you converted that into a categorical variable? Hello? Hello?
No. Yes, madam.
See,
Hello?
actually chi-square is used for the categorical variable. Suppose, see, we have shown you the education level, the below, what do you say, below secondary, then secondary education or above secondary, like that, or below poverty line and above poverty line. We have not taken the real income. We have grouped the income. Suppose you say that they put high fertilizer and low fertilizer. Suppose the category is there, you can use chi-square. But if it is a quantitative variable, don't make
kg, madam. Kg per house, madam.
Pardon?
Kg, madam. Quantity of fertilizers
That
in
is what
kg.
quantity. You don't go for chi-square. You go for correlation in that case.
Okay.
Suraj, kindly go for correlation. Don't go for chi-square. Okay.
Okay.
That is the reason all of us need to understand which test to be used, when to use it. For quantitative, we go for correlation. Suppose the attributes are there or the categorical variables are there, we go for chi-square to know the association. Okay. Is that clear? Anything else, Suraj? Suraj, any other doubt? Feel free to ask. Feel free to ask, because the more you ask, I'm happy, because it only means that either you have understood or you have so many doubts. That's all.
Yes, ma'am. Actually, in this table, they have used T value, madam. Difference between.
Yeah, that is very good. T value, if at all they have used, it is very good. How did they made it? Below means the average fertilizer or above fertilizer?
No, madam. Experience of farmers below 25 years, 25 to 35 years, above 35 years.
Very good. Yes, that could be. See, they have made two categories. One is below for 25 years and above 25 years. And they have used, is it significant?
Yes, madam. 3.31, significant.
Okay. What is the value of, what is the value, higher value for more experienced people? Category?
Higher value is subsidies, fertilizers in kg is 106.
No, that is true. That is true for the highly experienced farmers or low experienced farmers.
Experience, low experience, 25 years.
Okay.
Is highest utilized fertilizers.
Okay. That means to say, I think low means they are young also. They might have used better fertilizer compared to the older people. That is why they got the significant results.
Yes, ma'am.
Usually the young mind adopts very soon compared to the this. See, if you look at the student also, they adopt the technologies faster than us.
Yes,
even the IT or the mobile or whatever it is, right?
Yes,
okay. Suraj, any other questions? Or
no,
not only Suraj, anybody else? Any other example? Any other? Okay. I'll move on to the RCBD now. This table is very, very important. If you understand this logic, I think you will understand everything. See, this is on para. You can just see here, T1 treatment and T3 treatment are on para with each other. T3, T2 and T4 are on par with each other. T4 and T5 are on par with each other. See, in mathematics, we see that if x is equal to y, y is equal to z, then x is equal to z, but not in statistics. Because here we have error and we have the level of significance also, the probability. T1 is equal to T3. T3 is equal to T2, but T1 is not equal to T2. Please remember that. T3 is equal to T4, but T1 is not equal to T4. T3, T2 and T4 are on par with each other. There is no much difference. Whatever difference we are observing is just due to chance factor. And similarly, T1 and T3 are on par with each other. There is no difference statistically. That doesn't mean that T1 is equal to T2. T1 is only with T3, it is on par with each other. Whereas T3 is on par with T1, T3 is on par with T2, T3 is on par with T4 also. And if you take the T5, it is on par with T4. Is this table clear to you? Hello? Suraj? You have used
Yes, ma'am.
Yes, ma'am.
Yes.
Is
Yes, ma'am.
clear? Okay, okay.
Yes, ma'am.
Okay. Shall I move on to the next? Last topic, that is RCPD. The case studies some we have. You can just see between the groups. See here, degrees of freedom, 26 and 14. Now the F is highly significant. It is the case of Ratnakala in the year 2022. The prospects of using entopathogenic nematodes against the pathology one. The agriculture people, you will understand in sweet corn. And here, some are, see here actually, those of them who have the same alphabet, they are on par with each other, which has, for example, the T2 is on par with the T3, and which is on par with the T5, which is on par with T6. And T7 and D.ed, that differs from others. In the second instar, if you take the A and A, the T2 and T3 are T3 and T5 and T6 are on par with each other, whereas others differ. You can just see, like third instar. There are three instar, first instar, second instar. Those of them which are having the same symbol, they are statistically on par with each other, which differs in different symbol, they differ significantly. Any doubts in this? Hello? Any doubts? Agriculture? Yeah.
Hello.
Yeah, please.
Ma'am, is superscript in the form of that 2-key test type?
Yeah. 2-keys test. Actually, I've not gone in deep into that. Whenever there are more than 10 treatments, you go for that. Otherwise, simple LST is enough. Critical difference is enough. Okay. Then this is the management of dry root caused by macrophomina in safflower. You can just see here also. The calculated value is greater than the table value. It's a work of Shravani in the year 2022, which is highly significant. There is significant difference between the treatments. F only talks about that. And here also, if you come to the treatment, see the CD value is given 2.54. You can compare, and whichever has more than the difference, which one table I have explained you. So I'll not go for the explanation of this. It is already 9 o'clock. And the T2 is on par with no one. And here in the bracket, you can see some of you, this transformation of data is also there. I'm not touching on that actually. The bracket, it is there, transformation of data, because it is in percentage. So we are going for transformation of data. Okay. Then I'll come to the randomized block design. Is actually, if the plots are not homogeneous, then we are converting the plots into blocks which are perpendicular to the fertility gradient, such a way that within the blocks they are homogeneous, between the blocks they are heterogeneous. And here we have two sources of information. One is treatment, another one is blocks, or one is rows, another one is column, in addition to the error. Error is always a part and parcel of us. So three, one is rows, one is columns, another one is error. Or treatment, then blocks and error. So specific point is uniform set of practices must be followed. The checks control are also local standard varieties. And here number of replications should be chosen such that the error degrees of freedom. This is a common thing, not only here, even in t-test also we say that there should be at least quite a sufficient number of respondents. The degrees of freedom should not be less than 12 because the F value becomes consistent only after 12 degrees of freedom. And the field van, you can have number of replication, number of treatment also. To give you an example, 7 treatments have been replicated 3 times. So total plots we require is 21, but in one block, 7 plots are sufficient. You can just see that R1, R2, R3. This is one block. R1 is one block, R2 is another block, R3 is a third block. It need not be having the same fertility gradient. You allot the treatment in R1 block separately, R2 separately, and R3 separately. Please, not everywhere. All the 21 plots cannot be taken equally. First, you allot in first block the treatment, then you go for the second plot, then you go for the third block. Now, let us see the statistical analysis of this. CD, the formula I told you then only, CD into table T alpha at 5% into standard error of the difference. Then standard error of the difference is square root of 2 into error means sum of squares divided by replication. Those of you who are using this, you will understand. Now, the source of variation 1 has increased, that is replication. All other things remains the same thing. So there is one more degrees of freedom, that is R minus 1. So what happens to the error? Error degrees of freedom decreases. So error decreases here, degrees of freedom. So also, so whenever you have only one kid in a family, he will get more resources. When you have 2 kids in a family, the resources decreases. Similarly here, replication and treatments are 2 sons, so error decreases here. Okay, now all other things are same. But here there is 2 null hypotheses, one for the treatment, another one for the replication. Interpretation, significant treatment means square would indicate significant variation among the treatment and vice versa if not significant. And you compare the means by corresponding CD, just similar to one-way analysis of variance or CRD, what I have talked about earlier. And if you take the case study, Akshita in the year 2022, the ICR, she has studied the character association and path coefficient analysis for fodder and cereal parameters in forage sorghum. She has used the RCBD only, or randomized block design, the 2 rows of 3 meters each. That and all, you need not worry. She had 50 genotypes and replicated 3 times. And you can just see here the mean sum of squares treatments and the error significant, which is been given by star mark treatments, which are the treatments which are 15 genotypes she has considered. The case study 2, that is genetic evaluation of sesamum germplasm for yield and root rot resistance by Shweta Yadav in the year 21-22 in Tamil Nadu Agriculture University. Here also she had 50 genotypes replicated twice in RBD. The plant breeding genetics department, she has used this. And you can see the treatments which are significantly differing, and the error also has been given. Replication is also significant. And the merit and demerits, it is simple. Even if some observation of some plots are missing, we can go for missing plot technique, which I have not touched upon that. And the efficiency is more and the accuracy is also more compared to CRD, because I told you the error decreases. These are the merits of demerits. Is when the missing values are numerous, means many missing values are there, the analysis becomes somewhat complicated, though we can do it. And the efficiency of error control decreases when the number of treatments becomes more than 20 due to increase in heterogeneity within the block. Any doubts in this? Hello? Hello?
Hello.
Yeah, I think.
Hello.
Okay.
Hello.
Yes.
Ma'am, I have doubt in CRD.
Okay, please.
Ma'am, CRD may randomize in CRD randomization
Completely,
of the
completely randomized design.
Design. Pot culture, you said that pot culture we can use because
Yes.
homogeneity
Yes.
maintained there.
Yes. Yes.
So pot, in pot, anywhere we can place pot or something.
Yeah. Pot you can usually you don't go and keep it under the sun, no? Like usually it is under your control, no?
Yes, sir.
Yeah, yeah. You can just see here. See the figure. See, can you see this? This is a CRD.
But it is in laboratory condition. Ma'am. Yeah, it is also it is homogeneous condition.
Yes. What about your pot? I'm
Uh,
not talking about plot. Pot is a small thing I'm talking about. Where do
yes,
you
ma'am.
want to keep it? Where do you want to keep that?
Can we keep outside the lab?
Yeah, you can keep outside the lab, but you have to maintain the same temperature. You have to maintain the same humidity if you keep it outside the lab.
Okay.
That is, I told you, local control should be kept constant.
Okay, ma'am.
Okay.
Yes,
Nikesh.
ma'am.
Okay.
Thank you.
Any other doubt?
No, ma'am.
Okay. Anybody else has any doubts?
Such a nice and wonderful session, ma'am. It was great.
Thank you. Thank you so much.
Yes. Thank you, ma'am. Thank you so much.
Any other doubts from anybody? Gopalji, you are there? Or you have
Yes,
left?
madam.
Yeah,
No,
any doubts from any of the participants?
Madam, you have covered mostly all the topics, and
Okay.
we have faculty from all different backgrounds. Like some
Okay.
are from medical background, some are of having agriculture, some are of.
Yes.
We have covered all the examples that is
Yes.
related to basic level also. So it is our task to download the papers related to the statistics. That is very not required so much equipment and all other costs that is related to the other experimental analysis. But these statistical analysis can be done easily. So I request all to download papers related to the statistical analysis and coordinate with madam, and also if required we will also coordinate. And in our field there are a lot of research related to the ANOVA and SPSS, and the main thing is that reliability test that is being going on in different fields. So as we go and search the papers, we find that a lot of papers related to the statistical analysis. So it is our duty to continue this deal and download the papers and do work from immediate effect and publish it. This may require the only the Excel, MS Office. Yes, madam.
Yes. No. Any doubts are there? I can spare some more 2-3 minutes. No issue. Any doubts from any of the participants? Hello, any of the participants?
Hello. Hello.
Yeah, please.
Ma'am, you said that for lab condition, we required constant temperature and climate.
Yes.
So if we put the pot outside from the lab, can we maintain, can we take research for that?
That is, you have to tell me because you are a researcher, right? Can you maintain that?
I don't think, ma'am, I don't think so.
That's the reason usually under the control condition, we go for CR, controlled condition. Where you cannot control, we don't go for that.
Okay, so every pot having same temperature and same climate condition, so there will be variations.
No, suppose you are keeping the pots under greenhouse. Have you heard of greenhouse?
Yes, ma'am, I heard that.
Okay, so suppose you have a greenhouse. Why do they build a greenhouse? To maintain everything uniformly.
Yes, ma'am.
So
Definitely.
under the green plot, we have a very large greenhouse in our university. So under that condition, you can go for CRD. There is nothing wrong in that. But
Okay.
when you keep it open, it is not in your control. Like.
Yes, ma'am. So open, we cannot use CRD in open condition.
No, that's what I said. See, open condition, can we control it?
No.
Oh, that's the reason we cannot use it.
So we will use either RBD.
There are
or
so many other designs also. I have not touched upon that because there are plenty of other design. Either RPD or incomplete block is there, then LSD is there. Then even you can go for augmented design also. There are so many, plenty of designs are there.
Okay, ma'am.
Okay.
Yes, ma'am. Thank you.
Actually, we have 2 courses on experimental design. I just cannot tell you in 5 minutes.
Hello.
Yeah.
Sorry,
Any
ma'am.
other questions? Any other question?
No, ma'am. Thank you.
Yeah. Sir, Gopal sir.
Yes, madam.
Any other doubts? Any other doubts? Gopalji?
Yes, madam. We have a simple one doubt. If you have
Please.
time, you can
Please.
please.
Yeah, please.
There is some test that is related to the alpha reliability in SPSS.
Okay.
Cron batch test. Can
Okay.
you please enlighten us about this test?
No, actually, sir, are they going for scale development?
Yes, ma'am.
Scale development. See,
Actually,
whenever
the main thing is that we are from polymer technology background, and in this we may modify all the polymers and put these polymers into the different matrix and compare the results about the we study about the modification as well as the properties. What is the effect of this modification on the properties? As we go increase the degree of resolution, what may be the effect on the properties? This can be studied.
Okay, actually, as far as I know, like you can send me that. I'll study that and
I may send you the paper.
Yeah, paper.
Actually, one paper from reviewer send me.
Okay.
So we have to review this and give their comments. So I will send to you.
Yeah, please, please, please. That would be better. Okay. Any other doubts? I think today that lady is not there. Last time she had plenty of doubts.
Hello.
She's not today.
Yes, ma'am. I have one doubt more about ANOVA and CRD. What is the difference and when we will use ANOVA? When we will use
ANOVA is nothing but analysis of variance.
Yes, ma'am.
It could be one way, it could be two way.
Yes, ma'am.
Okay. Experimental design is the design we are using it. In CRD, we are following one-way analysis of variance. Because the source of information is only one treatment. The other thing is error. Whereas RCPD, it is two-way analysis of variance. Hello?
Yes, ma'am.
Yeah, two-way analysis of variance where we have two sources of information. One is treatment, another one is block. Or one is row, another one is column.
Okay.
Okay.
Yes, ma'am. But what is the difference when we will use?
That is what I said. Suppose you do not know, in the plot we talk it as CRD and you lay down experiment. Simply we are analyzing it without knowing any design, one-way analysis and two-way analysis.
Yes, ma'am.
Okay.
For comparing mean only.
Yeah, comparing mean. See, why don't you go for t-test? Why do you go for one-way analysis of variance when you have more than two means? Whenever we are comparing any two means, we are having 5% of risk. Suppose there are 10 treatments to be compared. So each comparison will be added with 5% of risk, 5% risk like that, which will be more than 100. So to compare at once, we are going for analysis of variance. Then the design used is either CRD or RCPD or LSD or things like that.
Okay. Okay, ma'am.
Any other doubt? Any other doubt from anyone?
Madam, you have.
Hello, ma'am.
Yes, please. Yes, madam. You have developed a societal tendency index. Can you enlighten us about this index? in 2 minutes?
Yeah. It is actually, sir, I had a mega project on that. So what happened is we visited some farmers who have committed suicide. You cannot visit the farmers, their family members, deceased family members. And there are two types. Those of them who committed suicide, who did not, control group was also there. So a big questionnaire was there. Then so many factors have been considered, especially their income, then the behavioral stress, behavioral pattern was also considered, then the loan taken from the vendors or the money lenders, then the bank and things like that. There are nearly 150 variables. Based on this 150 variables, what is their behavior? And we have reduced by using the principal component analysis. What are the factors which are really influencing their death? So this is an index developed based on the principal component analysis. Factors, what is elicited from the principal component analysis. So it actually, the logic regression is used where only two categories are there. The person who commits suicide, who doesn't commit suicide. So Y becomes a categorical variable, whereas other variables are all the quantitative variables, X1, X2 like that. So based on that, we have developed an index, and in that, three factors were found to be very, very significant. One is the person who is undergoing stress. Then he first is stress, then he goes to depression, then the depressed person goes to a behavioral changes, like you know better than me, because those of them who are in the medical field, he goes to a severe depression. Then he need to consult a psychiatrist. That is first factor which is causing. Then the second, because so many farmers would have taken loan, they don't commit suicide. And the second one is the crops. The commercial crops, suppose only one crop has been grown, because once the crop fails, his entire year has gone. So that is the second one, the type of crop. And the third one is those of them who have taken loan from the money lenders, because money lenders, you need to pay them whether your crop is successful or not. So these three are the main factors which were contributing for this. So based on this, we have developed a suicidal law. And one of the recommendation was we need to have a counseling center in the university, 24/7, so that farmers can call us and we can divert their calls to either. Suppose it is based on psychiatric thing, we have a psychiatric center nearby, demands. So we could divert their call. We have had a 24/7 counseling center also. Suppose they have some the income or revenue related, some property related, we diverted their calls to the revenue department or engineering department or electricity department, like that. Okay.
Very nice. So,
and documentary film was also developed based on regional language, which has been handed over to the government of Karnataka. But they just kept it in the cold storage. They did not do anything.
In 2017, Best Documentary Film Award goes to.
Yes.
Very nice.
Hello.
Thank you, madam.
Yes.
Yeah. Ma'am, I just wanted to add to the Gopal sir's question. Maybe I may be right. He was telling about, is there any other alpha reliability? What I know, alpha reliability or and this.
I asked him to kindly pass it on to me. I'll study that paper and then get back.
I may send immediately.
Yeah, please.
No, ma'am. I have a little bit doubt about this. It is just
after going
mostly
through the paper, madam explained.
Ma'am.
Yeah.
Hello.
Hello.
Ma'am,
please.
only is it the Kronberg?
May I know your name, please?
Ma'am, Gulzar Ahmed Khan.
Okay. Gulzar, tell me.
Ma'am, is it only about this Kronberg alpha where we check the internal consistency of the items before we are administrating?
No. Actually, it is to know the consistency or the precision. There are different ways of doing it. One is do and redo it, or after some intervals and things like that. So kindly send me the paper. I'll study that. As the alpha value is higher, you say that it is more precise or consistent. That is in a nutshell, I can tell, but however, I'll study that. As the alpha value increases, the consistency is better and whatever you have developed is better. That you can see. Okay. Any other?
Ma'am, in continuous to this, ma'am, I just wanted to confirm from you, while I am preparing a questionnaire, mostly in case of this alpha, Cronbach alpha or item consistency, we go for multiple items to know the consistency. Can we also check this on single item, single option answer or two option answers? Because mostly in case of internal consistency, we check the reliability of a construct, not
single item, single answers you cannot, because you will get only similar answers. Suppose whenever the answers are similar, the standard deviation will be 0. You cannot calculate anything. There should be at least minimum of 1 or 2. 2 at least.
Okay. Thank you, ma'am.
Anything else? Gopalji? Otherwise, if there are
yes,
no,
madam.
I think today we had more doubts than that day.
You have covered a lot of things, so that's why.
No, I'm happy.
This may open the mind.
Yes. So shall we wind up? I should thank all of you for the patience hearing. And
I request all the participants, is there any question, please ask it, otherwise we will conclude.
I think so. But only thing, that day participants are different from independent sample t-test. Gopalji?
Yes, ma'am.
These participants are not consistent. You have to use now the consistency for the stable pair t-test, who all are consistently participating in the training program.
Yes, madam. Madam, by attending this FDP, one problem that we feel that is this may help to the others. Is can we develop a model related to the slow learner, fast learner, and all these things? Can we develop a model that is related to statistics?
No, actually, there are so many already developed scales are there, sir, for slow learners. For see, there are 3 categories. One is above average, then the average, and the slow learners. And slow learners, actually, we have a department like human development. They have developed so many scales under that.
By the use of statistics, can we develop some other models that
definitely. This is not only one character which is contributing to that, sir, because we usually feel that those of them who get higher marks, they are academically good. It is not only that. There are so many other behavioral which contributes to the thing.
Yeah, in national education policy, all the things are covered, and the syllabus is as per the Bloom taxonomy, and this may not only works on the remembering level, but the student have to be at the creative level. So,
and first of all, we have to identify who are the slow learners. That identification itself, we have a scale. To understand, because in a class you have 30 students, how do you identify whether they are slow learners or fast learners?
We can take a test. We can take a test and then decide.
Yes. Not based on their academic performance.
Yes.
Because some of them may be really good, but they may not study, and means their performance may be slow learners is nothing to do with the below average marks. Those there are so many behavioral characters which belong to that particular category.
Yes, sir.
Anything else, sir?
Thank you, madam. Now I conclude the session. I would take this opportunity to thanks to the madam, honorary speaker, madam, for taking time out their busy schedule and making it happen. Without their cooperation, this may not be possible. And Madam has also give some suggestions regarding the topics that should be in chronological order. Otherwise, this may not be possible. So, Madam has engaged in from the beginning and gives their valuable suggestion so that this FDP gets successful. Now, thank you, Madam. You have, and thanks to all the wonderful participants. Thanks to the IT team for their support, and I also thanks to all the participants and who stuck with us at till 9:25. But the session is from 7 to 9, but they will stuck at 9:25. This is definitely they are wonderful. Thank you.
Thank you.
I thanks to all. Thanks to Madam.
Yeah, I thank all the participants for their patience hearing. And this lecture, I was contented because there were so many questions. Only when the participant question, the lecturer feels happy, whether they've understood or there is scope for improvement. So thank you so much. And I request Gopalji to get me the feedback so that we can improve. Suggestion, critical comment.
Yeah, tomorrow we will give the feedback form along with the test. And the other thing is tomorrow is the valedictory function, so all have to give the valuable suggestions in 2-3 minutes, 1-2 minutes, and about the speakers, and even thanks to the speakers who have given their valuable time in spite of their busy schedule. They are along with us. In 14 days, we are conducting this program from 7 to 9. So we must have to be very thankful to our speakers. And thank you.
Thank you, Gopalji, and all the participants. Good night and very best in your life. Thank you so much.